Okay, let's start. Fine. So, fine. Yesterday, I think we were looking at the thread group class, right? The class called thread group. And I think we had seen that we have two constructors. And what was seen was, yes, we have got two constructors. Constructor where we could specify a parent, which is nothing but a parent, and second was a string for the name. Right? These can't be changed. So when you create a thread group, or you could specify without specifying a parent, just giving only the name. Right? And then we have only get methods, no set methods. So the name and parent can't be changed in a thread group. Okay. So we only have methods to return void. We have not returning void. Sorry, we have the method for fine. We had method, for example, where method to return a string. Method called get name. Another method was to return thread group get parent. Only get method, no set method. Okay, you can't change the parent, you can't change the name. Okay. Then the other thing which we are trying to understand was thread group also has it's a place it has got that there are childs which are child threads under this thread group. And when we create a new thread object, when we can in the construct of thread we will specify a thread group to which this thread belongs. Fine. So fine, in a thread group we don't say, oh, I want to add a particular thread here, right? We don't do it that way. Yeah, when a thread would be created, it has to be under some thread group. A thread always belongs to some thread group. Okay, fine. And then the one thing was, we have certain methods which are group methods. They are methods of thread available in thread group. Methods of thread available in thread group. If you invoke on the thread group, all the child threads, that method gets invoked. Fine. Instead of invoking interrupt method individually, each and every child thread, a certain, oh, they all belong to the same thread group, I can call it on the thread group. So all threads under this thread group, we want to call the interrupt. Fine. So that can be done. Fine. So for example, yes, we had the method to return void. Name of the method was interrupt. Okay, what interrupt does? Yes, we'll have to understand interrupt in the thread class. What interrupt does in the thread class. Okay, fine. Fine. Let's try to understand this interrupt, which is available in the thread class. But there are other methods which I'm going to list here. They're not methods of thread group now. Okay, we're just trying to understand the meaning of what is this interrupt method, what it does in thread class. It's available in thread group. The idea of doing it in thread group is do it on all the child threads. Clear? We know thread group has a hierarchy of, it manages threads in a hierarchy, tree structure. Fine. In tree structure, all thread objects can be managed. That's the idea of a thread group. So if you call on a thread group, all threads would be getting interrupt. It's invoking interrupt on all the threads. Fine. Let's try to understand interrupt on a thread object. So back to thread class. Okay. Some of the things now we are looking at is a thread class. Okay. Fine. So in the thread class, again, the same method available. I'm not repeating this, but there are a few other methods related to the interrupt available in thread class. What is interrupt going to do for us? Okay, so it's something like this. We have an object of thread. Sorry. We have an object of the thread class. Okay. Think of something like interrupt is something nothing but there's one kind of a flag which is managed in this object, a boolean flag. Fine, which value is maybe by default initially it would be false. Okay, one flag whose value is false. Okay, calling interrupt would set the value to true. On a thread object, fine, on a thread object, if we invoke interrupt, if I say interrupt, okay, it should set this to true. Interrupt means set the flag to true, set it. Fine. So we have method in the thread, interrupt method available to set the value to true. Fine, we are looking at a thread object, not the thread group now. Okay. On a thread, if I call interrupt, the interrupt, there is a flag, call it as an interrupted flag. Okay, the interrupted flag becomes true. And we have a method in the thread which returns boolean is interrupted. Fine. So you can know what is the state of the flag, whether the interrupted flag is false or true. Initially, by default, it should be false. If someone calls interrupt, it will be set to true. Okay. Fine. There's one more method. Now, this is a method on the object. Is interrupted is on the object. Interrupt is on the object. Fine, which works on an object. Now we have a method which is not on the object of the thread. It's a static method in the thread class. Fine, so we are looking at a static method in the, so thread class has a static method. Fine, return type is boolean. Name of the method is interrupted. The method is interrupted. So there's a method called interrupted. It returns boolean, but it's a static method. So it's not on a specific object. Okay. See, for a thread object, there is a thread of execution which is executing the code. Fine. If I think of interrupt, anyone, any other thread of execution may also invoke the interrupt. Anyone who has the thread object, fine, can invoke interrupt. So setting can be done. Fine. But when someone uses the interrupted method, it's not on the object. It affects the current thread only. It affects the current thread. Interrupted is doing two things. It is resetting the flag. So who can reset the flag? Only the current thread. No one else can reset my flag. Clear? Every thread has a flag. Fine. For a thread, there is a thread of execution. Fine. That's a one-to-one. So for a particular thread object, the interrupted flag can only be reset by its thread of execution. No other thread of execution can reset its flag. This flag cannot be reset. They can set, anyone can set the value. Can say, oh, I want to make it true. You can make it true, but it can't be reset to false. Resetting to false only with the help of interrupted method does it on the current thread. Resetting of flag on the current thread. Okay. Is interrupted? Yes, anyone can find out what is the state. I can read the flag, but I can't change someone else's flag. Fine. You can't change, you can't reset. You can only set. You can set it to true. You can't reset. Clear? Setting is okay. You can do setting by calling interrupt. Okay. Clear? Three methods. Interrupt is interrupted. Those are instance methods. Interrupted is a static method. And so others can't, only the current thread can reset its flag. That's one thing. This is basically some kind of a signaling mechanism. Fine. Interrupt is nothing but a signaling mechanism. Others can put the signal, they can't reset the signal. Fine. And what is this method returning? Interrupted method returning? I said it's doing two things. It's resetting the flag, but it is also returning what is the current state of the flag. If someone has set it, fine, interrupted will return true. If it was already set, it will return true, but it would have been reset after it. Fine. So calling interrupted means resetting is done. But what was the value? That is what it returns. It returns the value what was existing there. But it's going to become false with this method. It might be true or false. Fine, whatever it may be. So it's like, I have read the signal. Someone else set the signal and I read the signal. No one else can read my signal. It's meant for me. So this is for reading the interrupted signal and resetting it. I have read it. Okay. Fine. So this is nothing but some kind of a signaling mechanism. Fine, between the thread. Okay. Now there is another thing which happens, which is related to this interrupt method. If this thread which is executing, okay, which corresponds to this thread object, it might be in a waiting state. This might be in a waiting state or a timed waiting state. Fine, there are certain methods because of which it will be going into a waiting state. Someone says, oh, you need to sleep for 5 seconds. Okay, it's in a waiting state, timed waiting state. Fine. Okay, so what happens here is, if someone calls interrupt on such a thread object, fine, this is a thread object, the thread here is waiting. It might be even waiting for an IO. It might be waiting. For some reason, if it is in a waiting state or a timed waiting state, and if you call interrupt in such a case, you are setting the flag, but then when you set the flag here, whatever is the method here which has put it in the waiting state, that method comes out. That method would throw an exception, and it throws the interrupted exception. So interrupt is not throwing it, okay? Remember this, it's not the interrupt method. These methods do not throw exception. We have method, for example, what is the method which takes it into a waiting state, a timed waiting state? There's a method called sleep, which is available here. And there's a method called sleep, which is available here. Okay, sleep method with maybe the timeout that can be specified in milliseconds. So you got sleep, right? So if this one is called sleep method, this sleep method throws, fine, this sleep method, for example, has a throws interrupted exception. There's a class called interrupted exception. Okay, it's a checked exception, but that's been thrown by some of the methods which are putting it into the waiting state or the time waiting. Fine. Some examples of the methods. One method is sleep. Sleep is overloaded. Fine, I'm not writing the other form. But similarly, just like we have method sleep, there's also a method called wait. Wait method, recollect, it's a method of object class. Fine. So someone a thread here might have called, and this thread of execution might have called a wait method on some object. Fine. What's the purpose of wait? We'll come to it later. But if it is in a wait means yes, it is in a waiting state. Sleep is also waiting or time waiting state. If it's in that state, while this is executing wait and someone says interrupt on this thread object, what would happen is that method sleep and wait, these kind of methods, what they do is they'll immediately start execution. They'll reset the flag. It resets the flag here. The sleep method, the wait method, they would reset the flag and throw an exception. I've been interrupted. Fine, they start by resetting the flag and throwing an exception. The exception thrown is the interrupted exception. Yeah, so interrupt method, which is in the thread class, fine, available on thread object. Okay, in the thread group, if you invoke it, yes, it's like invoking on all threads in the thread group. Fine. What interrupt does? It sets the flag, interrupted flag. Fine. In case the thread on which you are setting the flag, if it is in a waiting or a time waiting state, fine, that method which put it in the waiting or time waiting state would throw an exception and come out. Fine. It will start by throwing an exception. It will reset the flag and throw the exception. Immediately resetting flag and throwing exception would happen. The exception thrown is the interrupted exception. Fine, clear? This is one method. Now we'll look at another. There are three different methods, and all these three methods are deprecated. Fine, we'll see why those methods have been deprecated. That we should try to understand. Okay, so we have three methods which are available in the thread group as well as in the thread. We have those three methods. We had listed it yesterday, I think. We have the method returning void. Name of the method is suspend. Other method is resume. Yeah. What is suspend and resume? And of course, there's also a method called stop. Yeah. What are these? First one. What do we understand by suspend? Yeah. We have one thread object here. Okay. Let's say this is the thread object. There is an execution which is going on. Right? When this is executing something, and there is some other thread of execution, right, who has a reference to this thread object, and he says suspend. What does suspend mean? What would happen when someone says suspend? Simple meaning, what does it mean? Huh? Yeah? Hold. Who has to hold? Other one? Right. So other one, there was other thread, he was doing something and said, oh, you suspend. What will happen if such thing is allowed? Right. You're allowing someone to say, okay, you hold where you are. Fine. The one who is saying suspend, does he know where is that person? What is he exactly doing? On what state he is? Let's think we have a method in the account class called transfer funds. What it does? We have to specify amount. We have to say from this account to this account, transfer of funds must be done. What will that method implementation be? Oh, it has to first withdraw from one account and then deposit into the other account. Oh, it is going through this process, and someone says, oh, you suspend. Because you don't know what exactly state he is in. See, you can't stop a method. You can't just suspend a method at any point of time. Fine, within a method, fine, whatever, we have a method, let's say, right? This is my method body, okay, the code for the method. Within the method, there are logical points where you probably can, if someone suspends, it's not a problem. Otherwise, fine, you are going from one state to another state, from one state to another state. You are in between. The things can be inconsistent. Fine, you are doing something, you are making some changes where state of some of the objects would be something which is not consistent. Fine, clear? You have to do the whole thing or you don't do the entire thing. It has to be done atomically. Who decides it? Who knows it? Who knows about where it can stop? Does the other thread know where he can stop? Where exactly he is? No. Who can decide? Only the current thread can decide where I can stop. You can't just suspend me at any point of time. Yeah, we understand this? Fine. Oh, yeah, he's doing a transfer and you're saying, oh, he's just withdrawn and he's not deposited. He's suspend. And then there is some other thread who is saying, okay, let me take the total funds which is available in the bank. I don't find the amount tallying. Where is the money gone? Fine, if I take the sum of all the balances, no, it doesn't match. Fine. There was someone who was suspended. You can't do that. Yeah, so we have state, right? Yeah, it you can't. So the idea that someone else can suspend me is a wrong idea. It's only the current thread. The thread itself has to decide. Okay, I can now. So that's why that interrupt kind of a thing. It's a signaling mechanism. Oh, I got a signal. After I get a signal, I can decide where I should stop, whether I can stop or not. Fine. When I should stop should be my decision, not someone else just stopping me at any point of time. Clear? Suspending. So suspend is deprecated. We understand why. See, it was in 1.0. These three methods, suspend, resume, stop, they were added in 1.0. 1.1, they were deprecated. Immediately it was realized this is a mistake. So they have been deprecated right from 1.1, Java 1.1. Okay? Clear? So suspend, resume, and yeah, suspend is, what is resume? You suspend for some time, you call resume, he should continue from that point onwards. And what is stop? Fine. Stop is? What is stop? See, one thing. Fine. With the real world, if I compare, what is suspend? What is suspend? Statue. Resume is off. And what is stop? It's like killing someone. Shouldn't be done. Okay. So those three are deprecated. Yeah. It's fine. I had given some task to someone. Fine. And then okay. Recording on. Clear? Why these three methods have been deprecated? So they are deprecated in the thread class. They are also deprecated in the thread group. Both the places. Three methods are deprecated. Okay. Right. Now let's look at a few other methods of the thread group. One thing is structurally what is available in thread group. So from structural point of view, okay, thread group is used for organizing threads in a structural manner. Fine. Now it's only related to the live threads. Okay. You create a thread using a thread group, right? Okay. Now if you have started, fine, and the thread has not yet completed, then it is a live thread. If the thread has completed, it won't be available in the methods of thread group. Fine. Let's see what methods we have. I want to get what are all the threads under a particular thread group. So on the thread group object, you would like to know how many threads are there. So we have method like this. There are a few methods which is available. We have method which returns int. We have the method called active count. Returns int. How many threads are currently active? Okay, active count. Fine. There's another, no, we don't have a direct way of saying, okay, what are all, give me all the thread objects. It doesn't have a method to straight away return a thread objects which are under a particular thread group. But what we need to do is we need to look at the active count and then allocate an array of our own, pass it as a parameter to a method called uh, what's a method? Uh, okay, there's one method called active count. There's also another method. Similarly, there's a method called active group count. This is because there can be child thread groups. Fine, thread group has child thread groups. So how many child thread groups are active? One second, let me quickly. Fine. So we have the method called active count, and then we also have another method called enumerate, which takes as parameter a thread array. So you have thread objects to be populated in this. It's a pass by reference which is here, okay? And this also returns int how many are currently active. Enumerate also returns the active count. But see, the idea would be I'll first use the active count, allocate an array, and pass it as a parameter to the enumerate method. But nowadays, we don't need this. From Java 5 onwards, we actually have that method which we have seen earlier called get all stack traces. Recollect, get all stack traces. It can give me all the thread objects. And then once I know all the thread objects, I can know that thread group also. There is a method called get thread group in the thread class. Okay, so that way I can determine, but this is another way which is available traditionally. Right? Enumerate method where you can pass a thread array, and we have the same enumerate method also available where you can pass a thread group array. So you can know what are the child thread groups. Okay. For this particular thread group, what are all the child thread groups? So that you can know. So hierarchical structure wise, fine, finding the elements that's available to us through enumerate method. And active group count is also there. Before you call the enumerate with a thread group array, you probably would first use the active group count, allocate an array of thread group, and then use the second method. Fine, so you can know all the child thread groups of a particular thread group. Okay, another thing was we have at the thread group level itself, okay, we have the method, there's a method which returns int, name of the method is get max priority, and method returns void set max priority. What is the max priority? Yeah, by default it is 10. Fine. So by default, a thread group max priority would be 10. But you can change that. Change that to a lower value. Okay, fine. When you set the max priority, fine, The idea here is when you change the set max priority in a thread group, the threads under that thread group, their priority is not going to be changed. Whenever you call the set priority on any thread, or when you create a new thread, its priority will be set. The priority will be set at that time. It checks with the thread group's max priority value. It can't exceed that. Okay, fine. For example, you might have, let's consider like this, that we have got one thread group object, fine, in which in which we understand initially the priority was 10, max priority was 10, max priority value, which is in thread group. This is my group. Okay, under this I have got some thread object, okay, on which the priority which I have set initially, maybe I have set it to 9. That's allowed. Okay, now someone comes and changes the max priority from 10, he changes it to 7, let's say. If it is changed to 7, the priority of this is not changed. The priority of that thread which is already existing is not changed. When you say set max priority on a thread group, it's not going to go to every thread under this thread group and see, oh, if anyone is greater, and let me reset them. No, that's not going to happen. It's not resetting anything. It's not changing. It's just managing this value here. Okay, now onwards, if someone comes here and says, oh, let me set the priority to 8. He says, let me set the priority to 8, it will become 7. Or let me set the priority to 10. Oh, it will become 7. Try to set any priority, it can't exceed the max priority in the thread group. This thread belongs to a thread group. When you set the priority on a thread object, okay, at that time the check is done with the thread group. When you create a new thread under this thread group, and the one who is creating, maybe he is creating it, and he is already running with the priority of 9, and he says, let me create a new thread object. What will be the priority of the new thread object? Normally it should copy from the creator, so it should try to set it to 9, but it would be set to 7. Clear? Max priority is a setting available in the thread group. Fine. A new thread being created under this thread group, or someone changing the priority of anything, at that time this will be checked. Okay, max priority is another value which is maintained in the thread group. Fine. Another setting which we have, you have a thread group, fine, this is my thread group, fine, I have created some threads and those threads have finished. There are no active threads under this, and then I can say, let me destroy this object. So you have a method called destroy. There's a method called destroy returns void. What does destroy method do? It marks the thread group to be in destroyed state. It doesn't, nothing can ever, except for garbage collector, no one knows how to deallocate the object. Destroying, if you think destroying in terms of deallocation, no, that doesn't happen with any method. Only garbage collector can do that. We don't have any method with anyone. Fine. So calling destroy means setting the state to, oh, it is in destroyed state. Once we have a thread group in a destroyed state, it can't be used for creating a new thread object. You can't have threads created under it. Clear? Otherwise, you have a thread group, someone can call a constructor of thread and use this thread group object. But you can't use a destroyed thread group object for creating a new thread object. Clear? We have the method called isDestroyed. To return Boolean, and you can know whether it is in the destroyed state or not. Here, whether it is in destroyed state or not, that can be found, and we can put it in destroyed state. Okay, fine. So two methods. Now one more point. If there is a thread group, it has some active thread already, and if you say destroy, fine. If there are active threads in a thread group and you try to call destroy method on it, that destroy method would fail. It can't. You can't destroy a thread group which has active threads already. Fine. So destroy can't be done. We have a different mechanism for such cases. What we have is another setting. Okay. Now this setting name is similar to another method which is available in the thread class, but meaning is different here. Okay. We have this method set daemon, which takes a boolean. Okay, daemon setting for a thread group. Now it's for a thread group and not, we are not talking about thread here. Fine. Is daemon. Is daemon and set daemon, two methods available on thread group now. Calling set daemon true, setting a thread group as a daemon thread group would mean destroy this thread group when all its threads become inactive. If it doesn't have any, as soon as it goes in a state where there are no active threads, then it must be getting destroyed. It's like you are marking it for destruction. Fine, destroy fails because there are some active threads, but you can always say set daemon. Once you say set daemon, yes, there are active threads, so it can't be destroyed, but when the active threads will finish, this thread group will become destroyed. That is the idea of set daemon. Clear? Marking for destruction. Okay. Now another method which we know already to some extent. What does thread group implement? Thread group is implementing thread dot uncaught exception handler. Recollect this. I had mentioned this yesterday. We have the uncaught exception handler and thread group implements this interface. There was one method in that interface. So thread group has that implementation of that interface. What is that method? What's the method? The method is returns void. Name of the method is uncaught exception, where parameter is two parameters, a thread object and the throwable object. When the implementation of this is there, what's the implementation of this method? What's the default implementation of this method? The default implementation of this method is to do the t.print stack trace. That's how you are seeing stack trace. By default, if your thread terminates because of an exception, what do we see? We see stack trace. And that's because of the thread group. In the thread group class, the default implementation is to print the stack trace. Fine. So these are some important methods from some of the methods of thread group class. Clear on thread group? Okay. Yeah. Now what we can do? Yeah. Back to thread. Fine. Or we can quickly do some practical exercises using just the thread class. We earlier have done the echo server, I think. Fine, we have done an echo server which is multi-threaded. Recollect, we created a class called echoer. Fine, we created one class called echoer. We'll make that echoer slightly generic. Fine, we'll generalize it slightly because currently the echoer requires a socket object. Fine, and then it reads on the socket's input stream and writes to the socket's output stream. But what is the kind of thing being done mainly? What is the service method doing in the echoer? It's reading from one input stream and writing to some output stream. Let's make it general that this input stream and output stream can be any input stream and output stream and need not necessarily be from a socket only. Fine. Read from one input stream, whatever will come, I'll put it to the output stream. Fine. Basically, that's the kind of job it's doing. Fine. And then we'll see how we can use it for creating very small, simple kind of networking applications. We would like to write our own TCP client. What is a TCP client? We don't want to use the telnet as a client, but we would like to write our own general purpose TCP client. Okay, what does a general purpose TCP client, what it should it be doing? It should be, first thing is, okay, the input should be where it wants to connect. So host and port number is the input. Once given this, it can create a socket object. Fine. Once a socket object is created, then what is it doing? It's doing two jobs. It's listening on the socket's input stream. Whatever comes from the socket's input stream is shown on the standard output. From input stream, which is the socket input stream. Output stream, system.out. Fine. Simultaneously, it's also listening on the keyboard. If anything comes from the keyboard, send it to the server. So listening on system.in, whatever comes here, put it on the socket's output stream. We have two threads working simultaneously. One listening on the socket's input stream, other listening on the keyboard, the standard input basically. Fine. So we can write our own general purpose TCP client. Fine. We can use that also to create our general purpose, we can create a very simple kind of a chat between two clients. Anything which comes from the first client should be given to the second client. Whatever comes from second client goes to the first client. Just connection between two clients. Fine. So these can very easily be done. Fine. We just need to tweak our echoer class slightly, and then we can have such things being created in very simple code. Fine. So let's look at that coding. Fine. And then later we'll be looking at other methods of thread class. Fine. We'll need to understand synchronization and other things. Fine. Okay. Yeah, we would like to share this. 1 second.